Hello folks, we come to the exercise 2.2 part 1. Like the part 2, like the exercise 2.1, there is a host of results that you should be knowing, and it's on the basis of those results that we are going to be doing the problems over here. Like always, since we have it in the textbook just before the exercise, please go through all the results and see that you have it at your tongue tips, so that it's very easy for you to apply it. So that's what we are going to do. We are going to apply those results and we're going to go about doing this exercise. The initial 4 problems, the first 4 problems, they are prove that questions. You have to prove that, and then later on it is finding value, and you have a assorted group of questions, all kinds of questions, and very important exercise, very interesting also, important from all point of view. You have it coming again in derivatives, so you have to have it clear over here so that it becomes easier in the derivative section. So let's start right away. They ask us to prove the questions, and it's there on the board. We have the first one, 3 sine inverse x. You have to show that 3 sine inverse x is sine inverse of 3x minus 4x cubed. Now this can be done in a number of ways. For our convenience, we are making a small assumption, and with the help of that assumption we are going to prove the result. So first we are making the assumption, let sine theta be equal to x. Obviously theta will become sine inverse of x. Then we will consider the RHS, not the LHS. We will consider the RHS because that's more complicated, so it's easier to reach this side. So sine inverse of, it's actually sine inverse of 3x minus 4x cubed, but we don't plan to work in x, we plan to work in thetas. So x can be written as sine theta, and x cube can be written as sine cube theta. So we've got sine inverse of 3 sine theta minus 4 sine cube theta. Incidentally, that is also the formula for sine 3 theta, right? So that will be sine inverse of sine 3 theta, because that's the formula. Now in the question itself, they've given us a domain. I have not written it, but the domain is there. With the help of the domain you can check, and you will get to know that this 3 theta lies in our principal domain, principal branch. So it's fair enough to apply the ideas of the inverse function, sine inverse and sine. They are inverses of each other, so that we are left with 3 theta. Now 3 theta, the theta we know can be written as sine inverse x. So that becomes the LHS. So since we got RHS equal to LHS, we have proved the result. That's it. So what we have done is, in order to show what they have asked, we have used one small assumption, and we have used that to show it. So next question is just shade of it, where again they ask us same thing but with respect to cos. So the same way we'll make a small assumption and then we'll try to show it. These are important questions. Couple of times it has been asked in the board exam also. So let's make the same assumption here. Let cos inverse x be equal to theta, or the other way around. So x will become cos theta. Both ways, whatever is required we will use. Now consider the RHS. So that will become cos inverse of 4x cubed minus 3x. That is cos inverse of 4x cubed means it is cos cube x minus 3 cos x. Again, it's very clear to us that this is the formula for cos 3 theta. 4 cos cube theta minus 3 cos theta, and here it is 3 sin theta minus 4 sin cube theta for sin 3 theta, and this is for cos 3 theta. So this is cos 3 theta. Again, as I have told you, the domain is being clear and is being given to us. If you take the domain, try to put all these values and see, we are in the domain comfortably, we are in the principal branch. So as a result, this cos inverse of cos, they will act as opposite the inverse operations. So you are left with 3 theta. It is like 3 into theta, so theta can be replaced by cos inverse of x, and that is our LHS. So since we have proved that LHS equal to RHS, we have proved the result also. That's it. Yeah, just on the basis of small assumption that we are able to do the work. So at the right time, that assumption has to come, and that's how we do this. Now this problem we are going to do with the help of that result. I have told you we are doing number of results, and that we are going to use over here. In the forthcoming problem, we are going to use this result. Tan inverse of A plus tan inverse of B is tan inverse of A plus B by 1 minus AB. So have that in your mind. It is this result that we are going to use there. So we'll start with the LHS. Consider LHS. So tan inverse of 2 by 11 plus tan inverse of 7 by 24. Please keep an eye on this result and see what will come. That is tan inverse of 2 by 11 plus 7 by 24 whole by 1 minus 2 by 11 into 7 by 24 by the result. Now the space is little insufficient, so you can refer over here, and this is the result. So now let's apply. We'll have to equalize it and see what is coming. Whatever way we'll equalize this into 24, this into 11, then this into 24 into 11. So 24 into 2 48, 7 into 11 77, 24 into 11, then 24 into 11 264 minus 14 by 24 into 11. Now numerator denominator, denominators can cancel, so they can cancel. Tan inverse of 48, 8 plus 7 15, 1 carry, 11 and 1 12, 125, 4 minus 4 0, 6 minus 1 5, 250. That's just double, yeah. 125 is double is 250. So tan inverse of half, and that's exactly the RHS. So what we did is just simple correct application of the formula that needs to be applied there. Yeah, so once we applied the formula, you're able to do the arithmetic or the algebra gives us the answer. That's it. We've proved that result. Next, we're going to the next problem. There also we are going to use the right formula, and that's how you're going to get it. This formula we'll be using, and you'll be also using the formula 2 tan inverse of x is tan inverse of 2x by 1 minus x squared. These two formula together is going to give you the result there. So let's check that once again. I don't know which position should be good to have unhindered sight. So let's have this, and let's see how this can come. Consider the LHS. So that is 2 tan inverse of half plus tan inverse of 1 by 7. This by the formula there, it will be tan inverse of 2x, and this is your x, okay. So 2 into half by 1 minus half square, 1 minus x square, that's a formula, plus tan inverse of 1 by 7. So this will cut. This will become tan inverse of 1 by 1 minus 1 by 4. How much will that come to? 3 by 4. Common sense, we know 1 minus 1 by 4 is 3 by 4. So 1 divided by 3 by 4 means multiplication by a reciprocal. 4 will be in the numerator, 3 will come in the denominator. So this will become tan inverse of 4 by 3 plus tan inverse of 1 by 7. Now we can apply this formula, this one, and check what will come. This will be tan inverse of 4 by 3 plus 1 by 7 by 1 minus 4 by 3 into 1 by 7. And let's check what is coming. We'll have to do all that equalizing work and all that. This into 7, this into 3, this into 21. So it is tan inverse of 28 plus 3 by 3 into 7 and 21 minus 4 by 3 into 7 if you want. So we have tan inverse of 28 plus 31 and this is 70. Are we right? Yes. RHS. Henceforth. Yes, so that's our result, and this is how we go about it. So these were the first lot of proof that problems, and this is how we are taking, we are using the result, and we are showing how this goes right. So with the next problems we are coming in the next video. Thank you.